Find the rate of change of area of a square with respect to its side when x equals 5. So the area of a square is x squared. Derivative of both sides with respect to x, and that will be dA dx is equal to 2x. When x equals 5, so that will be equal to 10. Find the approximate radius of curvature of the function y is equal to x squared minus 3x plus 1 at point 1, negative 1. So this is the formula for the radius of curvature. Meaning we need the y prime and the y double prime. So y prime was the first derivative. That's 2x minus 3. Substitute x as 1, so that would be 2 times 1 minus 3, so that would be negative 1. And our second derivative is 2. So substitute that on our formula. What is our radius of curvature? So this will be 1.414. Evaluate the integral of cosine squared of 2x dx. So let's use our calculator technique for this one. So let's remove the integral sign. So get the function inside cosine squared 2x. And then reset any value of x. And then, since we are dealing with a trigonometric function, let's put our calculator in mode regions. Let's say we choose x as 0.5. What is the value of the function? It is 0.2919. And amongst our choices, we will be performing derivatives on all of them. So, for example, for letter A, derivative of this function at x at 0.5, value is 0.0839. For letter B, same procedure, 0.2919. For letter C, 0.1661, that's negative. And for letter D, so that will be negative 0.8078. And to know which one is the correct answer, we will be finding which one matches our original answer, and that is letter B. Determine the length of arc of the curve y is equal to e raised to x from x equals 0 to x equals 1. Length of arc formula is the integral of the square root of 1 plus dy dx quantity squared dx. Meaning, we need to find the derivative of our y. What's the derivative of our e raised to x? That's also e raised to x. And limit is from 0 to 1. Answer will be 2.0 units. In mathematics, a quantity larger than any can be specified as infinity. Approximate area bounded by the curve y equals 8 minus x squared and y equals negative 2 plus x squared. So, first one, these two are parabolas and there will be two intersection points. To find them, let's equate the two equations. So 8 minus x squared is equal to negative 2 plus x squared. Solve that, x will be plus or minus square root of 5. So one step also is to draw the figure. But we can optimize the process by getting our area without the figure as integral of the absolute value. Meaning, regardless which is y up or y down, our answer will still be correct. So our L will be y up minus y down, and then our x1 and x2 are the limits of the function. So y up, let's say this is our first function, 8 minus x squared, and y down is negative 2 plus x squared, from negative square root of 5, from positive square root of 5. Area in our calculator will be 29.8 square units. The area of the surface generated by rotating any plane curve about a certain axis in its plane is equal to the product of the length of the arc and the distance traveled by its centroid. It is also called the first proposition of Pappus. Find the area bounded by y is equal to natural logarithm of x, y equals 0, and x equals e. So again, let's get the point of intersection. So let's equate the y. So that's ln of x is equal to 0. Ship solve, x will be 1. So area will be the absolute value of L and then dx. So L will be y up and y down. So let's say y up is ln of x and y down is 0. Limit is from 1 to x equals e. Answer will be 1 square units. Distance traveled by a passenger train is given by the equation x equals 3t squared plus 2t plus 4, where x is the distance in kilometers and t is time in hours. What's the velocity after traveling 10 kilometers? So we have the distance traveled. So when x is equal to 10, we can solve the value of time in hours. So time will be 1.1196 hours. And we need to find the velocity. And we know that is the first derivative. So we can use our calculator. So that's d dx of our original function. Just change t into x. And x will be the time 1.1196. Answer will be 8.72 kilometers per hour. What is the approximate total area bounded by y equals 2 sine x over the interval of x is greater than or equal to 0, but less than or equal to 2 pi? Again, area will be the integral of the absolute value of y up minus y down. Y up, let's say, is 2 sine of x, and y down, let's say that is our x-axis, or that's y equals 0. Limit is from 0 to 2 pi. Again, since there is a trigo function, we need to be in mode radians. Answer will be 8 square units.